Okay, Math 30-1. So now is when we put all we've learned together, the unit circle and standard position and the cast rule, all come together to solve trig equations in both degrees and radians. So the first thing you might want to do is just um, stop by and look back at unit circle. Could you find the points around the unit circle this? So take a moment and pause and see if you could fill that in and come back. So for example, as I do this, I just ponder. I remember the unit circle. If I thought about my triangles, and again, I'm putting my triangle right here, I'll go around the circle. Clearly, that is 1/2 high and root 3 over 2 in terms of x. And as soon as I've got that, I've also got this point here, which would be minus root 3 over 2 and positive 1/2. And this would be minus root 3 over 2 and minus 1/2. And last but not least, this point over here would clearly be positive root 3 over 2, but minus 1/2. And then I could do the other points. Oh, 45 degrees, that's a special triangle. I know that those points are 1 over root 2 and 1 over root 2. And then I know all the other ones around the circle. So this would be minus 1 over root 2 and positive 1 over root 2, and so on, connecting all of those triangles like we did on the unit circle. And I'm not going to finish all those off, but we could connect all those points. And lastly, our 60 degrees. Well, clearly when I look at this special triangle here, my 60-degree angle, I can clearly see that is 1/2 in terms of the x value and root 3 over 2 in terms of the y. And then all my related angles with that, my benchmark angles, would be right there, and I could know all those points. And lastly, these points here are 1 and 0, 0 and 1, minus 1 and 0, and lastly 0 and minus 1. So when we go to solve equations, we can actually use these things because we know on the unit circle, just combining, and if this doesn't make sense, please ask, but these are not mere points on the unit circle. What we know is that those points on the unit circle are really cosine of theta and sine of theta. That the y value of each of those points is actually the sine value of that angle, and the x value is actually the cosine. So when somebody says, what is the cosine of 330 degrees? All I do is look for the angle at 330, and that really refers to the fact that it's root 3 over 2, because that's the x value of the point at 330 degrees. So a very valuable piece of knowledge to have all that put together. Okay, so what else do we need? We need to be able to factor. Okay, we need to be able to factor. So factor x squared plus 5x plus 6, right? You need to know that. Go. When you did, you should have got a simple trinomial x plus 3x plus 2. But more importantly, some of us still struggle with tough trinomials. Go back. No decomposition or guess and check, but you need to be able to factor that. And if not, ask tomorrow. So try this one. Can you factor it? You don't need to use the quadratic formula. No. So when you factor that, you should have got 3x plus 1 times x minus 5. Okay? Can we do that? Next thing, we need to be clear about the difference between an expression and an equation. What are expressions? What are equations? Ponder that. Which of these above here are expressions and which are equations? And drag them or put an arrow into the right column. Put the equations where equations are and expressions where they are. What makes them special? Well, clearly, as we do this, that's an expression, that's an equation. That's an equation, that's an expression. What makes an expression? There is no equals. It's not a balance. There's no equals. It's not a left side and a right side. You just have an expression. What's simple, or what's not simple, but what you can do with these is all I can do is simplify. There's no solution. There's no solution to an expression. You can simplify and write an answer to it, but it's not like there's a variable there that you're solving for. Whereas equations, they do have an equal sign, and I solve these. And obviously the rules of equations that we've learned over the years apply, right? So those are equations. What are the things that we need to do as we solve equations? Well, we looked at questions like this in Math 20. Rewrite the equation and isolate the trig function. Okay, so hopefully that's clear. But it means when you isolate the trig function, it means you got to get sine theta by itself. Okay, so if you're going to get sine theta by itself in all of these questions, or cosine or tangent, then we do that first. Now we've done that, we now remember our Math 20. We know that it's positive, and I would much rather draw a diagram. So sine is positive. The cast rule says that it's going to be in quadrants 1 and 2, right? And now we need to find out the reference angle. What's the reference angle? Well, that's a special angle. Turns out a half only happens, if you go back to your unit circle, a half only happens in your special triangles at 30 degrees, exactly 30, right? So I put 30 degrees in quadrant 1, and I put 30 degrees in quadrant 2, and I get 30 degrees and 150. Those are my two answers, okay? If somebody asked for a general solution, you would write theta is equal to 30 plus 360n. And don't forget, you must write that. If you don't write that, if all you write is 30 plus 360n, you aren't writing the general solution, okay? You have to include that so that you're only doing complete revolutions, okay? Again, ask if that's something that doesn't make sense. So again, what do we have here? We have cosine theta. We need to rewrite and isolate the cosine theta, but not unlike you guys would have done questions like this in grade 9. If you had 4x minus 1 is equal to x, you'd collect your x's to one side and you'd have 3x equals 1, so x equals 1/3, right? But that's not what this is. This is cosine theta. So instead of doing that, we solve it for cosine theta, right? And that was silly. That's a typo. This should not be a negative. This should be a positive, okay? And so if we have that positive value, this is probably going to have it wrong. This is cosine positive, so don't look at that. So let's just finish this off by hand. So if I'm doing the cast rule, this is in quadrants where cosine is positive, which would be in 1 and 4. When is cosine equal to 1/3? Well, we don't have a special angle for that. We will, oh wait, and it says between 0 and 2 pi, right? So we're dealing with radians, so we got to make sure your calculator's in radians. So I'm in quadrants where it's positive, so I get my reference angle is 1.23. It didn't say to 2 decimals, but we can't have an exact value, so I put 1.23 in those 2 quadrants, and now I have my answers for theta is 1.23, as well as in my calculator I'm going 2 pi minus 1.23, so we fire that up, and what do we get when that happens? 2 pi minus 1.23, and we end up with 5.05. So those are my two answers. However, a general solution would be theta is equal to, now I'm going to put both of these, 1.23 and 5.05, and I'm just going to put a bracket like that, plus 2 pi n, where n is an element of integer. So Mr. K is being efficient or lazy, but I'm just putting both of those in one statement so I don't have to write quite so much, okay? So there was a little bit of an error. It wasn't a negative cosine, it was a positive cosine, okay? All right, so we'll skip through. Don't look at this. This is going to be incorrect because of that negative, right? We continue on. Now we got cosecant, right? Well, cosecant, again, we've talked, you need to rewrite this in terms of its trig function, but then you need to change it into actually working with sine, okay? So, okay, let's rewrite it. Let's solve it for cosecant first. When we get cosecant is equal to minus 2 over root 3. That's nice, but I don't have a cosecant button on my calculator. So I flip it over, and that's the same statement as sine equal to minus root 3 over 2. That's a special ratio. Root 3 over 2 happens at 60 degrees. So, but again, we'll do the cast rule. Y is negative in quadrants 3 and 4. I would rather draw a diagram. So in 3 and 4, it's negative. We have a reference angle of 60 degrees. That's nice. And so that means that my angles of theta are this one and this one. 60 degrees is not one of my answers because it's negative. So my answers are really 240 or 300. And as a general solution, it would be 240 plus 360 n and 300 plus 360 n. And don't forget, n is an element of integers. Uh-oh, gotta watch. Notice the restriction is 0 to 2 pi. And that's important. 2 reasons. It's radians, obviously, but also you have to watch. If they put 2 pi, they want the answer as an exact value if you can. So you have to have multiples of pi in your answer if you can. So if we solve this, we take the secants to one side, we take the 3 over there, we get secant is 1. We take the reciprocal, that means that cosine is equal to minus 1. Oh. That happens in quadrants where cosine is negative, right? Now, 1 is kind of a special one. They call it a quadrantal angle. You'll see in a second. But don't worry about that. You don't have to have that memorized. Cosine is negative 1, so where is cosine negative? Well, cosine is negative in quadrants. Whoops, let's have a different color. In quadrants, cosine is negative in quadrants 2 and 3. Now, what's the reference angle for negative 1? The reference angle for negative 1 is, okay, I think I might have said the reference angle for negative 1. We don't want that. We just want to know the reference angle. And the reference angle, don't put a negative in. The reference angle for 1 is 0 radians. So if you put 0 right here and 0 right here, what you end up with is an angle of, therefore, my angle is pi. And if 0 degrees right here, that answer is pi as well. It's the same. It turns out to be the same, right? And there isn't any other angle it could possibly be, right? The other way you could look at this is, when is cosine minus 1? And so if you look back to our very first slide, when is the x value negative 1? And looking at the unit circle, the x value, if you look over here, the x value is negative 1 only at that angle of pi. So connecting our unit circle to these questions is helpful. And you can see around the circle some of the other questions that we asked. When is the sine of theta equal to 1/2 or root 3 over 2 or whatever? We can use this as well rather than using reference angles and so on. Okay. Coming back. Okay, so there was our answer for this. So x equals pi plus 2 pi n is an element of integers. Cool. Now, we've dealt with radians, but how about when we start dealing with squares? As soon as you have squares, you have to remember our square root property. So the sine squared is a half is a tricky question, because when you take the square root, and I'm just going to put this here, x squared is 4. When I ask that question for $1 million, typically nobody gets a million because everybody says x equals 2. When that's only half of the answers, because x equals plus or minus 2 when you are taking the square root. So in this case, we got sine squared equals a half. That means that sine equals plus or minus the square root of a half. So sine theta equals plus or minus 1 over root 2. I don't really care if you put it as a rational denominator, because that's not really what's going to happen. We just need to know that because sine could be positive or negative, there are 4 possibilities for where this angle could be. And when I find out the reference angle, which is in degrees 45, but I don't want 45 degrees. I want the reference angle to be pi over 4 because I have 0 to 2 pi. So if I put pi over 4 in each of these, as long as you're good with fractions, this is a piece of cake, because this is pi over 4. This is 1/4 less than 1 pi. So that's going to be 3/4 pi. And then the next one would be 1/4 more than pi, which would be 5/4. And the last one is 1/4 less, right? 1/4 less than 2 pi. And 2 pi is 8/4. 8 minus 1 is 7/4. Some of you might change it to degrees, but you must express your answer in exact values, and it must be in radians because the restriction was in radians, okay? You can't put them all in degrees. That's not what was asked for, okay? In question B, cosecant squared is 4/3, so I take the square root, which makes plus or minus 2/√3, but cosecant, not cool. I flip it over and make it into sine. Sine theta is plus or minus √3/2. It is both positive and negative, so I'm going to stop drawing the diagrams every time. It's in all 4 quadrants. When is sine equal to √3/2? If it was degrees, you'd say 60, but I'm not going to say 60 because it's pi/3. And I put pi/3 in all of the quadrants, okay? And just like we did in the last one, 1, 2, 3, 4, pi/3 in every quadrant, you end up with pi/3 and 2 pi/3 and 4 pi/3 and 5 pi/3, okay? And again, you could have done it as 60, 120, 240, 300, and then change them back, but you need to have your answers in radians, and they need to be exact because that's the restriction that was set. Okay, carrying on with different degree 2 equations. If you had 4 sine squared equals 3, again, probably more than enough questions in this. We'll go through this one too, but again, sine theta is plus or minus √3/2. Again, the reference angle for √3/2 is pi/3. You need to put it in all 4 quadrants. We need to put it in all 4 quadrants. All right, so just like we said, in all 4 quadrants, and those are your 4 answers, right? So sometimes, or now we need to go into things where it actually involve factoring, which is what we talked about at the very beginning. So if I was given this question again, just think of this, and we don't necessarily see it as clearly when we see signs, but if I asked you in Math 20 to solve 2x squared plus x equals 0, you would factor out the x, and you'd have 2x plus 1 equals 0, and therefore you'd say, solving by factoring, x equals 0 and x equals minus 1/2, and all would be good. Well, this is the same situation, except for instead of having a variable of x, you have a variable of sine. And so now you say that sine equals 0 and sine equals minus 1/2. But that's not the end of the story, because now you have 2 trig equations that need to be solved for, and we do. Sine equals 0 is a quadrantal angle, and if you look at the unit circle, sine equals 0 at 0 and pi. Notice I didn't even do any work. I just used my unit circle. It's a special situation. I'm not doing it with reference angles, right? But sine equals minus 1/2. Again, I could look back at my unit circle. That's going to be, again, quadrants 3 and 4. My reference angle is pi/6. And as an exact value, it turns out to be 7 pi/6 and 11 pi/6. Okay? In the next example, again, look at this as though you are just factoring like you would in Math 20. If you factor it with sines, you get 2 sine theta minus 1 and sine theta plus 1. So sine theta, just seeing what it equals, that would mean that sine theta would equal 1/2, or sine theta would have to be minus 1. If you want to use reference angles and so on, right, it's pi/6, it's in quadrants, we're positive 1 and 2, so that's 5 pi/6 and pi/6. And sine equals 1 at 3 pi/2, okay? And again, I did not do the reference triangles and all that because this can be just easily seen from the unit circle, okay? So at the y value is minus 1 at 3 pi/2, okay? F. Oh, now we're starting to get into questions where we had to factor a little deeper. So again, if you were saying 2x squared minus 7, this is a tough trinomial. So if you factor this tough trinomial, I'm not going to go through decomposition. I'm just using guess and check. You do whatever you need to, but you need to factor that to 2 cos minus 1 and cos minus 3. Therefore, cosine theta would equal a half, or cosine theta equals 3. If cosine theta equals a half, you find your reference angle, and your reference angle is pi over 3, which makes my answers in quadrants 1 and 4, so 5 pi over 3 and 5 pi over 3. And you can't get a solution for 3 because the adjacent side's not supposed to be more than the hypotenuse. So you could never have a cosine value of 3. There's no solution to that. All right. And lastly, in G, if they already factored it for you, well, then all you need to say is that, first off, the restrictions are degrees, so sine x must be 1 and tangent x must be 1. We can go through and see the reference angles. Oops. But in this case, there is only one place where sine's going to be 1, and that's 90 degrees. And the only place that this isn't true, tangent would be 1 at 2 places. There's a little bit of a hiccup there. So this one is a quadrantal angle, but tangent equals 1. My reference angle is 45 degrees, but I would put it in quadrants where tangent's positive, which is here as well as here. So it'd be 45 and 45 here, which would make angles for x. X equals 45, but it also equals 225. So there's 2 places between 0 and 360 where that equals tangent equals 1. Okay? We'll work through these assignments in class tomorrow. See you guys tomorrow.